Okay, I think I'm sharing my screen. Okay, so hi, good morning, good afternoon, or good evening, depending on where you are. I'm Bernardino Martin, and I'm part of the customer success team at Rated Power. We in the customer success team, as the name suggests, we ensure success of our customers. Our main task is that customers master PV design and feel satisfied with the software. To achieve this, we provide technical support, personalized technical support, in such a way that your goals, the goals of our customers, become also our goals. In this way, all the product improvements come in hand with a real need, and basically our roadmap is the result of the feedback of our customers that we receive. Today, we are going to do a webinar regarding the topography of PV design, how to import them, and how to convert the formats. This webinar has arisen because lately some PV design users have been asking us how to convert topography data from different formats to XYZ format. Also, another frequently asked question is how to convert some restricted areas that come in CAD files or shape files to camel or camset files in order to define our site inside Google Earth. And after these two steps, we are going to see how to apply some filters in the topography tab inside the software, inside PV design. And at the end, we will see some documents generated by the software. And then if you have questions, I will be glad to answer them and so on. So let me stop this presentation and I will start sharing my screen. So I think now, okay, I'm sharing the first monitor. Okay, screen one. Sharing, I think so. Angela, let me know if I'm sharing my first screen in the chat. This, okay, thanks. Okay, so first of all, I want to show you. I will turn off my camera so you can see better the screen. Okay, so here we can see the desktop. I have the inputs that we received from other team, and basically we have an AutoCAD file that defines some of the restrictions of one of the project. So we are going to do like a real case scenario, okay? Okay, so here we can see the available areas and restricted areas that are defined in AutoCAD. We can also see some land constraints defined in AutoCAD. And we also have some topography file, a native file, okay, it's a TIFF format. Okay, to do all these conversions, we're going to use QGIS. So let me open QGIS. Okay, to be able to import and export camset files to QGIS, I recommend you to install first a plugin. Okay, to do so, we need to go to plugins, manage and install plugins, and here we can see all the plugins of the company that we have installed and are available. Here we can look for KML and we can find the KML tools. We just click on install and we have it. In my case, I already have it. Okay. Now that we have the plugin, we can also install other plugin called Quick Map Services to open maps in the background. So we'll open the Google Earth map so we can always see where we are, where our site and our project is. Okay. So first, to import the DXF file, we need to go to project, import, export, import layer from the X file or DWG, so basically CAD files. First, before importing the drawing, we need to create a package file. Okay, to do so, we just click on these three dots. We look for a destination and we just write a name. Okay, I will use this one that I have already created. Test. I'll save it. Okay, then we click on import. The file that we want to import, in this case, the land constraints. In this case, they are in, let me check if they are in WG. Yes. And this is the coordinate system for 258. It's important to select the right coordinate system here. 258. So when we import the files, they appear in the right place. Okay. Okay. Okay, I think this is not the file that I wanted to import. Sorry. This one. Okay. And the 4258. Okay, now import. Okay, close. Sorry. Now I need to put a name to the group. Sorry. Let's forget this. Test. And click on OK. We don't want to merge the layers because we want the layers separately. Okay, we just have this layer imported. We can zoom to the group. Okay, I will put them up on the background. So here we can see now the polylines that we had opened before in AutoCAD. These ones here are the restricted areas. Okay. Okay. If we want to convert these lines into polygons, we can use, for example, the. Okay, let me check. We can give a thickness to the polylines using the vector tools, geoprocessing tools, and giving them a buffer. In this case, they're in degrees because we are using coordinate system in degrees, but we can change it to meters also. This is just an example. Yes, run it, and we have now polygons instead of lines. We can define them as restricted areas. Once we have converted all the layers and so on, we can right-click. We can select the layer that we want to export one by one. For example, this one as a restricted area. We can go to Vector, KML Tools, the plugin that we just installed. Export CAMSET file. We select the layer. Here in the bottom, we define the place where we want to save it, and we just select a folder and a name. Okay. I already have done this process, so I will go directly to Google Earth and to open the file, the final site defined. Okay, so we can go to Nachos. This is the project we are doing. Okay. Here we can see all the layers. I will show them one by one. So here we have the rivers for the flooding areas that we just created in QGIS and exported to KML files. We have also the other restricted areas, other flooding areas, but they are polygons. We have the available areas, some other restricted areas for the buildings, and we also have defined some shortcuts. These shortcuts can be created by using path. We have a guide in our knowledge base explaining how to create shortcuts and how they work, but basically we can use them to predefine pre-existing roads in the site, or we can also create them to define how to cross with the roads the restricted areas. Okay, so that's it. Here we can also add an access point, a secondary access point, a substation polygon, and 2 medium voltage points, one for the available area and other for the substation. Once that we have defined all these elements, we just save the full KML file as the full folder as a KML file or CAMSET file, and we go to PVDesign and upload it. Okay, let me open PVDesign. Okay, so here I have just login. Here we can see all the projects of the company. I will just create a new project. I will call it webinar click on Start Design. And the first step, as always, is to upload the file that we just created. Okay. PVDesign is taking different information from different databases, like the metadata, the topography from Google Earth, and other information like the horizon and the albedo. Okay, the site is loading. So we can see it here. It's already inside PVDesign. We have the persisting roads and all the elements. And here we can see the topography of the file, of the project. This topography is the one of Google Earth, but as I was explaining at the beginning, we have our own topography that has a higher resolution than this one, and we want to convert it. So to do so, I will go back to QGIS, and we'll try, and I will import this layer. Okay. So now that we're in QGIS, I will delete all these layers because they're not important now, and I will go. This is the TIFF file is a raster layer, so we go to raster. No, sorry, this is, we are going to open this tab later. First, we need to go to data source manager. We click here on raster exactly, and we select our raster file. Okay, the full top of this file. We just open it and we add it to our project. Okay, we can see it here, but in this topography file it's quite big, and we just need a part of it, the part that is inside the available area. So I'm going also to import with the camel tools the background, only AA. So now we have, we're going to try to cut this raster layer and to keep only the points that are inside the available area. Once we have this extraction, we will convert it to XYZ format to import it to PVDesign. Okay, the first step is we need to go to vector, not to raster, extraction, clip raster by mask layer. The input layer is going to be the topography file, and the mask layer is going to be the polygon that we just import, the available area. Here it's important to choose, we need to choose the source of the, so we can choose the coordinate systems here, but in this case, we don't want to convert them yet because we want to convert the final file, the XYZ file. Okay, so I will just run this, and now you can see that we have a new mask layer that is just the polygon. Okay, now that we have this file, we can click on raster conversion, and we are going to convert this format, so translate the format from the mask, so the mask layer, the raster layer, to an XYZ file. Okay, here we need to choose the right coordinate system, the one of PVDesign. To do so, I'm going to open PVDesign again. Here, if we go to show details, we can see the coordinate system that PVDesign is using. Okay, so 32629, and I can overwrite it here. But in this case, it's the same coordinate system, so I don't need to change it. But it's important to keep that in mind because sometimes we're using a different coordinate system, and PVDesign is not going to accept our cloud point. Okay, the last step is to select a place where we want to save it. Okay, I will call it webinar and just save it. Okay, this conversion has been done. I will go to the desktop where I save it. I have it here, and I can open it with it's called Studio, but so I can open it with how is called this, this software, Notepad, sorry, and or Code Studio. I will use Code Studio because it's faster. And here we can check that the file is working okay. This is the X coordinate, the Y coordinate, and the elevation. In this case, we can see that we have a lot of negative elevation. This is because we cut our raster layer, and all the points that are outside the raster layer are defined with this value, this negative value. To do so, we first need to delete all these rows. We just click Control F, and we are looking for this value everywhere. But if we click here, and we just paste this expression, we are going to select all the rows that contains that negative elevation, and we want to replace them by nothing because we want to delete all the rows. Okay. Now we can save this file, the XYZ file. We have all the coordinates and the elevation. Now it looks better, and we can go to PV Design and upload the topography. Okay, I will choose all files. Open. If I did everything okay, yes, I did it. We can check the topography now here. And now we have, we can start designing with a high resolution topography. Here we can define the slope limits. For example, you can see that in the higher part, in the northern part of the site, we have slopes above 20%. And here in this area between 20 and 15%. And so on. So you can play around a bit with this heat map filter to see the different arrows and the direction of the slopes. Okay, now that we can start with the design and see the topography limits. But first, I will go directly to a design that I already have here, so we can go faster. We go to our nachos, and we just clone this design. Okay. It's the same file, but with all the configuration of the equipment and layout already done. This is the same project. Okay, if we go to topography, here we can define the filters that we want to apply. First, we need to enable this option to discard all the structures that are above the limits that we are going to define. Here in topography, we can define the structure installation limits, the slopes, the maximum slope that we want to set for the structure in the north-south direction and the east-west direction. I will change here the power requirements to maximum capacity. And I will play a bit with these filters. For example, here we can see that the north part we don't have structures, but if we set a higher limit, for example, 20% or 40 in the east-west direction, the peak power is going to increase. And more structures have been installed. Okay, so, and the other way around. We can also apply some earthwork filters, but today I'm not going to see that because we are going to do a webinar in the future where we apply all these earthwork filters, and where once we launch also our new version of the topography and earthworks that we're working on. Then we can also apply some terrain undulation criteria, where we can set the maximum tolerance, undulation tolerance for the post, and discard the structures. Okay. In this case, we have some structures discarded due to the undulation tolerance. Okay, we'll go to back to the project to check the documentation. we can see today, for example, here we can see the final design, okay, with the shortcuts that we define, the power stations that are placed, the roads, the medium voltage lines, substation, and so on, okay. Let me show you some documents. For example, some documents are related to the topography. We can open the general layout in camel file to see it in Google Earth. We can also open the 3D layout. We also have the PV Colada file that is a way to export the 3D layout to PVSys, but I don't have PVSys in my computer installed, so I can show you this right now. We can also check the topography analysis, the DXF file, and the listing of posts that is related to the topography analysis. I already have these files in my computer, so I'm going to open them. Okay, here we can check the final design in Google Earth. This is a good good way to see how the PV plan is going to look like. We can see that we didn't install structures in the restricted areas that we said. Then I will open also the topography analysis. Okay, here we can see all the slopes, the arrows. Okay, let me open the layer properties. I'm going to hide all these arrows. Okay. So we can see now the structures and the pose of each structure, the position of each pose. We can also enable the structural codes. And these codes are related to the Excel file that we will see now, the listing of posts. We open the 3D layout in the meanwhile because it's going to take time while it opens. Okay, I'm back here. So I open the listing of posts. Here we can see all the structure, the identification code of each structure. We can see the coordinates of each structure, and same for each file of the structure. So for example, here we can check the code of the structure, the pile row. In case we have fixed structure, we can have more than one, and the pile number. We also have an histogram with all the pile lengths. And last, the 3D layout. So we're almost done. I'm trying to open the 3D layout, but if you want, you can start asking questions. Let me try to open the questions because I can see them. Okay, here we can see the 3D layout. Is the topography. This topography is the one that we imported from GIS. Okay. Okay, I will stop sharing my screen. I will share the presentation again. I don't know if you can see my screen and my face. Okay, let me check the questions. Okay, I'm not able to see them. I don't know why. Can you send them to me in the chat, Angela? Because I'm not able. I can see them. I don't know why. Okay. Can we see the costing analysis, please? Okay, so yes, we can see the cost analysis. Let me share again my screen, this screen. So here in the index, in the files that we just downloaded, we also have the financial analysis where we can see all the costs. This is basically the capex, the way how we calculate capex. And it's based on the peak power in this case because we just set a basic template based on the peak power. Okay. To create new templates, we just need to we can go to capex template and add new templates here. We can define the capex templates based on the units of the bill of quantities. For example, instead of defining the prices as a function of the peak power, we can define them as a function of the number of modules, the number of inverters, the power of the inverters. We can give a price for each box also, and so on. Okay. The next question: does it include yields? I think it's related to the cost analysis. In this case, no, we don't consider cost as function of the yield, just as a function of bill of quantity units. Then the next question: where did I get the topo file? Okay, this topo file was shared from, I found it, so someone shared it with me, a customer. But yes, you can download it from some public database in the internet, or you can also get it from some surveys, like that you can do on the site. Could you share the recording? Yes, all of you will receive an email with the recording and all the documents and resources that I have mentioned, so no worries. And also for other users that want to maybe to see how to convert these files. Okay, next question. Is this a tracker system? Can do you layout for fixed tilt array with different row spacing distance to follow the topography of the site? Okay, this is a good question. Currently, this was a fixed tracker system, single axis tracker, but you can choose also here on equipment other structures like fixed or east-west structures. In this case, if we use fixed structures, the pitch distance or the distance between rows is going to be fixed for all the sites. So we are not considering the topography when defining the pitch distance. It's a fixed value. But thank you for your question and the feedback. I will share it with the product team because it's a really interesting question. Does PSN recommend specific values for the slope limits? Yes, when we create a new structure, here when we upload a new structure to PV design, we define the slopes limits here based on the manufacturer, okay? So in this case, it's a generic structure, but we can upload structures based on some data sheets of some manufacturers, and we are going to get this value from there and upload it to PV design. So once you enable the filters here, the topography file, we get directly the recommended value of the manufacturer, but you can change it. So basically, this data we get it from them. Can we include near shading and far shading in the design? Okay, this is also a really interesting question. We do near shading analysis between structures, and we also do. If we go to energy here, we can see the results, and we also get far shadings from the horizon. But we are not considering a 3D energy model, so these near shadings are only considered between structures and in 2D. If we want to simulate in 3D, we have this PV Colada file that you can import later to PVSys to do your 3D energy analysis and also to include some near shading objects. Also related to this, we can see here in the energy tab the far shading, the horizon. Okay. Okay. Do you have more questions? Mm. Can we upload control lines for the topography? Okay, so you cannot upload them directly. If you have your control lines in AutoCAD, so in DXF or on CAD files, on any other CAD file, we can upload it to PV design doing the conversion first in QGIS, similar to the same conversion that I did now. But we don't really recommend you to use directly control lines because when you convert them to XYZ values, we lose some information because basically the count points is like a mesh where you have a lot of points and these other control lines are not that the quality is not that good. So you will have some like some wet slope maybe in your design. Also, this has to be this is related to how our interpolator works. Yeah. So I think if there are no more questions, that's all. So thank you for your attention and all your questions. We will share this video later with everyone so you can see it again and check all the details and see how we convert files. So thank you very much.